rectangles, rhombuses, and squares. And the first thing we're going to talk about is a rhombus, okay? All of these today, notice, are parallelograms. Tell me what you know about a parallelogram.
They're congruent.
Opposite sides are congruent. Opposite angles are congruent. Consecutive angles are supplementary, okay? All of the things that you know to be true about a parallelogram are true of these three things. But now I'm going to give you more things that are true specific to these three, okay? So first of all, a rhombus is a parallelogram with four congruent. Does anyone know the word that comes after that?
Angles.
Not angles, it's sides. Yep, four congruent sides. So a rhombus often looks kind of like this, where these are all the same, but it's not usually set up rectangular, right? With the right angles. It can be, but it doesn't have to be, okay? So that's a rhombus, four congruent sides, but all the things of parallelograms are true. So opposite angles are congruent, opposite sides are congruent. If I draw the diagonals in, they will bisect each other, all those details, okay? Then we have a rectangle. A rectangle is a parallelogram with four congruent, what?
Angles.
Sides.
Angles now. More specifically, they don't just have to be congruent, they are congruent and right. Okay, so four right angles, which means they will all be congruent. Okay, so a rectangle will often look something like this. Four right angles. So if I take a rhombus and a rectangle and I put them together, four congruent sides, four right angles, what do I get?
A square.
Square. That's the last one, a square. So a square will look like this. Four congruent sides, four right angles.
Draw a good square.
Honestly, if you draw the diagonals in first, it's probably easier to draw a good square. Okay, so these first two questions here, example one, says, is it a rhombus, a rectangle, or a square? And we got to think a little bit about what we're working with here. Okay, so just look at letter A.
A is a rhombus.
Okay, first of all, I am telling you this is a parallelogram. I should have written that in there.
This is an emergency.
Okay, this is a parallelogram. I want to know, is this parallelogram a rhombus, a rectangle, or a square?
Rhombus.
Now let's think about it.
No,
Square.
No.
I swear if you tell me that's anything other than a square.
Stop.
It's a rectangle because they're not
No.
all the same.
It's a rectangle.
We don't know anything about the side lengths, right?
Because they're congruent.
The only thing
Opposite
they've...
sides are congruent.
No, listen. The only thing they have marked for us is that that's a right angle. So in a parallelogram, let's think about this. True it.
Opposite sides
In
are
a parallelogram, opposite angles are congruent. So this would have to be a right angle. What do you know about consecutive angles?
They equal 180.
They equal 180. So that means this has to be a right angle. So they can tell you just one angle in a parallelogram. If it's a right angle, you can find all the rest of them. Okay? Even if it's not a right angle, you can find all the rest of them. If you know it's a parallelogram, one angle gets you all four angles. Okay? So this gets us four right angles. Do we know anything about side length?
No.
Did they tell us any length?
No.
Nothing.
No.
So it looks like maybe it's a square, but we can't say it is because we don't know that the sides are congruent. Maybe one is 2 and one is 2.1. Those are not the same length, okay? So the most specific name you can give this is a rectangle because we know it has four right angles. We don't know if it has four congruent sides or not. Does that make sense?
Yes.
So make no assumptions,
Wait.
okay? We do not assume.
I'm so.
The crazy thing is, I saw like a video on the internet about this very subject.
Yeah?
Yeah.
It's a popular subject, rectangles, rhombuses, and squares.
Like, someone was like, explain to me how this looks like a triangle.
Okay, on this one, there's a piece missing. I need you to mark this. Mark it in black, okay? So that you think it was there all along. Mark those two sides
I have a
congruent.
pencil, so it's going to be gray.
It's a square.
Okay, so let's say, and this A is not an A. Let's say we look at this picture and see the markings that are given here. Okay, so they have marked 3 things. They've marked these 2 sides are congruent, and they've marked that this is a right angle. Do you know any other angles in this figure if this is a parallelogram?
Yes,
What?
yes. They're-
Opposites are congruent, right? Consecutives are supplementary. So these would have to be 90 to add up to 180 with angle F. So we know it's a rectangle. We need to figure out, is it more than a rectangle? What do those 2 red markings, the hash marks, tell us?
They're like parallel with another.
They're equal to 90.
It is a parallelogram. We know it's a parallelogram. What do you know about parallelogram sides?
The opposite.
Opposites are congruent. So if this is marked this way, then so is this one. And if this is marked with 1 hash mark, then so is that one, right? So what kind of figure has 4 right angles and 4 congruent sides? A square. So even though they didn't give you all the markings that show square, you have enough to know that it is a square. Okay? Cadence, are you with me back there? Questions on that?
No.
Okay, so here are a couple theorems that you're going to use to find missing angle measures and things like that. The first one is Theorem 613. You don't need to memorize the number. It's just saying we're in chapter 6 and this is the 13th theorem that you've learned in this chapter. So don't worry about the number. But it says diagonals of a rhombus are perpendicular. Okay, let me show you what that looks like. And honestly, you guys, drawing the diagonals first is usually pretty helpful. So make 2 perpendicular lines, but then we want all the side lengths to be the same, right? So this is a rhombus, 4 congruent sides. Notice when you draw those diagonals in, this is 90 degrees. So in a rhombus, those 4 angles will always be 90 degrees. Okay, the diagonals of a rhombus are perpendicular. Remember, perpendicular means you're going to get 90-degree angles. Okay, the other thing that a rhombus does is that next theorem, and it says the diagonals of a rhombus bisect. What does it mean to bisect? Cut in equal parts, right? Cut it in half. It bisects a pair of opposite angles. So I'm going to use that same picture. Okay, just use that picture that you already drew. Here's what it does. It means this angle and this angle and this angle and that angle are all congruent in every single rhombus. Okay, it also means that this angle is congruent to that angle, which is congruent to that angle, which is congruent to that angle. So it's bisecting. It's cutting those angles into equal parts. It's not a kite. It's a rhombus. So in a rhombus like this, notice how many different angle measures you see. When the diagonals are drawn in, there are only 3 different angle measures. There's the right angles, right? Those 4. There's the angles that got bisected here, the purple ones. And there's the angles that got bisected here, the red ones. So you will only have 3 different angle measures in a rhombus when the diagonals are drawn in. Okay, lots of similarity there. Questions on that? Okay, so let's take a look at these pictures and see if we can figure out what the measures of our angles will be. So they tell us in the problem that this is a rhombus. What do you know about a rhombus? What's the definition of a rhombus? It's a parallelogram with 4 congruent sides. Okay, so all of these are congruent. We know that. It's a parallelogram, right? So what is the measure of angle 1?
100.
100. Opposite angles in a parallelogram are congruent. So this one is going to be 100 because this one's 100, right? Those 2 angles are going to be the same. Excuse me.
It's not mean, it's actually.
It is mean. That's mean.
No,
That's inappropriate.
Oh,
Okay,
it is.
fine, not mean. Inappropriate regardless of whether you think you're being mean or not. We don't call people names like that.
That's
That's what he
I
calls
don't
himself.
care.
It's like-
It's not
that's what
okay.
I was on my phone.
All right. Number 2 and 3. Angles 2 and 3.
2 is 80, I think. No.
I know why you think that, and you're on the right track. It's not 2 that is 80. It's 2 and 3 together that make 80, right? Because here's the deal. Look at this. This right here, right? These angles,
132.
okay? Those 3 angles, just listen. Those 3 angles are supplementary, right? They are same side interior angles, and same side interiors are always supplementary. These have to add up to 180. Well, I know because this is a rhombus that these 2 are the same measure. So you could call it X and X, or does anyone see an isosceles triangle?
What's an isosceles
I totally
triangle?
forgot what that was.
Isosceles triangle is this.
Oh, is that where like all the sides are like?
2 sides.
Yeah, or 2 sides. Are the same
Right?
and one
These 2 sides are congruent. So this is an isosceles triangle. You could look at it like that, meaning this angle will also be a measure, the same as the measure of angle 3. But really what happens here is all 4 of these are the same because the diagonals of a rhombus bisect the opposite angles, right? So however you want to look at that, just out of curiosity, how many of you would prefer to look at this with the same side interiors, with these angles?
Me.
I don't understand.
2 of you? 3 of you? How many of you would look at it as an isosceles triangle instead? Okay, so let's go same side interior.
I see a square.
I see it.
So you have this angle
I see.
with
Wait,
these
are we talking about the shaded
2.
part or the whole thing?
Right now I'm looking for 2 and 3. So I'm saying if you look at 100
Yeah, that helps.
with 2 and 3, right? This setup here, those are same side interiors. So we're gonna say, let's just call this X and X, right? 100 plus X plus X should equal 180, right? Those 3 together should equal 180. We're not sharing
Wait,
food right
so-
now. We're doing math right now.
Wait, so 32.
You may eat them, sure. We're not passing them
2 and
around.
3
But
equals
Focus
180?
for me. Say it again, Max.
Wait, 3 and 2 equals 180.
No, 3 and 2 with 100 equals 180. They're same side interior angles, remember?
Yummy in my tummy.
So if we put 3 and 2 together as one angle, that with the 100 is 180. No, this is just, 3 is not the measure of the angle. 3 is just saying that's angle number 3.
I'm okay.
So forget about 3. Call it X. Does that make more sense? It's just the unknown. We don't know it yet.
So why don't you read it, Shreya?
Okay? Okay, so here it is. You have 100 plus X plus X. So it's 100 plus 2X equals 180. We're going to take away the 100. So 2X equals 80. And then we're going to divide by 2. So X is 40.
On the
I
opposite.
feel like this is exactly
Hey, Truett, you go sit back there. You go sit right here.
I was confused when he had yogurt.
I don't care. You're talking. Why does it matter if he has yogurt? Just sit and listen. Truett in the corner. Forrest over here. Cadence.
Luke and I were saying like, there's 80 left out of the 100.
Right.
So then you just split it in half and it's 40.
That's what you did.
All the math.
Well, that's the math you just did in your head, right?
Yeah.
It's the same thing.
Okay.
Yeah, so X is 40. That means angle 2 is 40. That means angle 3 is 40. Angle 1 was 100. Okay?
Wait, can you keep it there?
Mm-hmm.
What Max said?
This next one, they draw both diagonals in, so that changes things a little bit. It's honestly typically pretty helpful when they draw both in because we know something in the middle here. This is a rhombus. What's the measure of angle 1? What was that first theorem we said? The diagonals of a rhombus are,
Same angle, kind of sides.
what happens here?
It's a right angle.
They're perpendicular, right? So if the diagonals of a rhombus are perpendicular, then angle 1 is 90 degrees. Yes, Max.
You think trucks should be white?
Trucks
Yeah.
should be white.
Yeah.
I don't care what color a truck is. Okay. The rest of this, look at your picture that you drew up top. We said the diagonals are perpendicular, and then we said the diagonals bisect angles. So how many total angle measures were there in this problem?
There was 9
There were 3 different angle measures, right? Look at what matches up. This angle here should be the same as this angle here, which is the same here. Trip, do you need to go?
No, I'm sorry.
Pull it together. So those 4 are all going to be the same. I don't know. Nope. So what is the measure of angle 2?
50.
2 is 50. What's 3?
50.
3 is 50. Okay.
How much is 4?
Yes. Now how do we find 4? So this is 50. This is 50. This is 50. These are all 90.
So the answer is
180
No.
minus 90 minus 50.
Yes. Okay. So look at what Dakota's saying here.
Sorry.
You have a triangle. Do you see the triangle here?
things he's dandy drops.
In that triangle, you have the measure of angle 4, 90, gentlemen, shh, and 50 that make a triangle. So those 3 angles have to add up to 180. So take away, this is 140, right? So take away the 140. And that means the measure of angle 4 is 40. Does that make sense? So once you have that your diagonals are perpendicular figured out, and you find the 4 that are congruent here, there's usually a triangle somewhere that you want to set equal to 180. Okay? Look for that. Okay, last thing is dealing with rectangles now. So we said the diagonals of a rhombus are what?
It's the same
Or
Perpendicular. Okay? That's a rhombus. The diagonals of a rectangle, look at this picture. Do these look like 90-degree angles?
Yes.
No, they are not. Okay? The only time a rectangle has perpendicular diagonals is when it's a square. Okay? So the diagonals don't have to be perpendicular anymore. The diagonals of a rectangle, though, do have something true about them. Any guesses what's true of FD and GE? They're the same. They're congruent. Okay? So the diagonals of a rectangle are congruent. So what that means is if I have a rectangle with the diagonals drawn in, okay, this will be 90, 90, 90, and 90 because it's a rectangle. I know that every one of these is congruent, okay, because the diagonals as a whole are congruent also. So if this is A, B, C, D, I know AC is congruent to BD. Okay, the whole diagonal is congruent to the whole diagonal. So does anyone know why we know then that all 4 pieces are congruent? Like, couldn't it be that the big one's congruent to the big one, but then the other parts are not?
No.
It could be. But we know that the diagonals of a parallelogram bisect each other, right? So if the whole thing is equal, then when these bisect, that means all 4 of those little pieces have to be equal as well. Okay? So diagonals of a rectangle are congruent.
That's it.
Last thing. That's it. So look at this. It says FD, this right here, is 2y plus 4. GE, this right here, is 6y minus 5. What do you do with those 2 expressions?
Set them equal.
Set them equal. Okay? You're going to say 2y plus 4 has to equal 6y minus 5, and then we're going to solve that. So take away the 2y, and you get 4y. add the 5, and you get 9. Okay, so those go away, those go away. What's your next step?
Divide by 4.
Divide by 4. So y is, you could leave it as 9/4. I would probably call that 2.25. You can just plug that into your calculator.
Me too.
You get 2.25. 9 divided by 4.
Mm.
Okay, so last question then. If that's our setup, and we know that all 4 of these are congruent, what type of triangle is HGD?
And isosceles.
It's isosceles, right? This triangle right here,
Where you got isosceles from?
because we know that these parts are congruent.
Oh.
So that's an isosceles triangle, which is helpful, right? Because we know isosceles triangles have congruent base angles. So technically, we know that these 2 angles are congruent if it's a rectangle.
Because one side is
Okay? Any questions on that?